Hi everyone, I am Bhavarno, and in the last video we have already talked about center of gravity and how it affects. Now in this video we are going to talk about a new kind of motion, that is circular motion. So if I ask what do you mean by circular motion, I know everyone can answer that. What we know is any object which is moving in a circular path is said to be in circular motion. It is as simple as that. Now, there are some parameters or some effects involved in the circular motion and how the forces are being acted on an object to move it in a path which is circular. So, our main objective of studying the circular motion is to deal with the parameters, forces, how it acts, and the effects imparted on the body which is moving in a circular path. So, today's topic of discussion is circular motion. Now, if we classify this motion on the basis of its uh, time interval and the distance traveled in the time interval and the speed and velocity acceleration of the body moving in the circular path, we can further classify circular motion into two parts. One is uniform circular motion and the other one is non-uniform circular motion. So most of us already knew about what do you mean by uniform and non-uniform motion. So in this case, what we have already known is that uniform motion is the motion in which the object travels equal distance in equal interval of time. This is all about uniform motion. Or if we talk about non-uniform motion, it is just the opposite. That means it does not travel equal distance in equal interval of time, or it travels unequal distance in equal interval of time or unequal interval of time. So this is about uniform or non-uniform motion. But when you talk about uniform circular motion, the first parameter is constant. That is, it will travel equal distance in equal interval of time. Okay, so to move a particle in any path, we already know that we should impart some force into the particle so that it will possess some motion. So definitely the circular motion, the object moving is also imparted by some force that is acting on the object, and it is making it follow the circular path. So in this case, this object will also have some speed. For this, the speed remains constant. But we all know about speed versus velocity. Okay, we can call speed constant if the magnitude is constant over the time, over the time of action. If the magnitude is constant, we will say that the speed is constant acting over the body, no matter in which path the body is moving. But in case of velocity, there are two parameters which define if it is constant or not. That is, one is magnitude and the other one is direction. When we define velocity, we have to define along with magnitude the direction in which it is acting on the body. So if we say the body is having a speed of 10 km per hour, let's say 10 km per hour, then it is constant all over the path. It is moving with 10 km only. But when we will say the what will be the velocity of the body? So what we will say then? Because every time the object is changing its direction, at every instant of time it is changing its direction. That means what? If the direction is changing, something is changing in its velocity also. And what is that? That is the direction. And so as the direction is changing, this is changing. So we call the velocity is, definitely the velocity is not going to be constant anymore. So we call it as, this is not constant. And now comes, when we call any velocity that is not constant, we call the motion to be accelerated. Because as what does that mean? The velocity is constantly changing. This means that velocity is changing. If v is changing, that means there is some delta v with respect to time. And when we say delta v with respect to time, what does it mean? Acceleration. So it is simply, from here we can simply observe that when we are saying that the velocity is changing with time, that means the motion is already accelerated. There is no question in that. So due to this, we call that the motion is already accelerated. So now in this case, the speed is constant, but velocity is not constant. Together with this, the motion is accelerated, but it is traveling equal distance in equal interval of time. So hence in circular motion there can be no case where the velocity can be constant and there will be no acceleration. So that we have already defined the uniform circular motion in this case, where the velocity is not constant but the distance traveled will be equal in equal interval of time. But when you talk about non-uniform motion, the case is different. And I think you have already guessed what is going to happen in this case. There it will not travel equal distance in equal interval of time. Is that clear? The velocity will not be constant in this case also. In this case the motion is also accelerated, but what is differentiating them is the distance traveled. If it is equal in equal interval of time, we call it uniform, and if it is unequal in equal interval of time, then we call it non-uniform. So it is all about uniform and non-uniform circular motion. Now let me rub this. Okay. Now let's move to our next topic. Before that, I want you to analyze something or observe the motion and how it is moving. Let's say you tie a ball with a string or with a rope. Okay, you then try to revolve it. Okay, so when you are revolving it, you are constantly feeling feeling that some force is acting outwards, or you can say that when you are revolving the ball is constantly trying to get out of the head and it want to flow away. So what is happening? This is what you have felt. I think all of you have felt that once in your life. So whenever we, let us say that this is the ball and this is the string with which the ball has been tied. Now we are revolving it. Okay, so when we are so the ball will possess a circular path. It will move in this way. It will move. So what you have felt that some the ball is trying to escape from the path. Have you ever observed that? You are revolving the ball in this direction and suddenly you let the ball to fly away. So what you have observed is that the ball tries to escape in a direction, or it flies away in a direction which is tangent to the circle or tangent to the path it is following. That means always, every time when a body is imparting a circular motion, the velocity vector is acting in a direction which is tangent to the path of the motion. So if we draw a diagram of circular motion, we will get that this is the path, this is the object moving in this direction. So this becomes the velocity vector. So if we draw the this is the velocity vector acting in this direction. So when the ball moves to this point, then the velocity vector acts in this direction. Now in this point it will act in this direction. Sorry, it will be in this direction. Yeah. Okay. This will be the velocity vector, and similarly in this case it will be the velocity vector. So at every instant of time it is changing its direction. The velocity is changing its direction, and whenever you let the ball escape, it will follow the tangential path. Okay. So now if I say that whenever something is possessing a circular path, circular motion, then some constant action of force is required to hold that object in that path. How? As I have said, if I let the ball fly away, then it will not follow the path. Inertia will not act in a circular direction. We have all heard about inertia. The object at rest will try to be at rest, and objects at motion will try to be at motion. But this is the case of linear motion. Okay, a object can't possess circular motion having being in the state of its inertia. So to uh, to move in the circular path, there is some constant force is required. So if we talk about that constant force, something should pull it, or something should make it hold in that path. So what is that force? The force which is holding it in its actual path or the circular path, we call that force as centripetal force. So what is that? It is the inward force, inward pulling force, which makes the object possess its circular motion or circular path. Okay, it will always act in the inward direction, because it is acting in the inward direction, and that's why it is holding it in this path. Or else, if this force is absent, it would have it will fly away. If the force is not there, the ball will try to fly away. It will fly away. It will not try, because the this horizontal velocity will be the inertia force. That means if we the body will try to move in this direction, if no other external force is acting, that is the inertial effect of the force on the body, but not the circular one. So the centripetal force is the force which is holding the body into its path. So if we so it will act towards the center of the path. Okay, that's it. Now now uh, if we take an example of a string and some mass is tied with it, now the string will possess some force of tension in the mass, which holds it back. So in case if it rotates in a circular path, then the tension becomes the centripetal force. Okay, so every holding force that is holding the object in motion becomes the centripetal force. For if we consider a sun and the planets moving around the revolving around the sun, let's say it is Earth. So what is the force which is holding the Earth in its orbit? This is the force of gravity. So this is the centripetal force here. Okay, whenever you are making a turn in a circular road, okay, this will be the centripetal force, this will be the velocity vector. So here the centripetal force is being constituted by the frictional force. Whenever it tends to turn, there acts a frictional force in this way, which holds the car in its path. Okay, so this is all about centripetal force. Now you have already heard about one other force, which is centrifugal force. Before starting the centrifugal force, I want to state that it is not a physical force, and it is not a kind of force which actually exists. It is just a fictitious force which does not exist. This is only the reaction we feel when the centripetal force, we know that every action has a reaction. When the centripetal force tries to hold ourselves towards the center of the path, we feel a outward force, which is the reaction force in the outward direction. Okay, which seems to pull us out of the path, and this effect of force we call it as centrifugal force. Let's say you are traveling and there is a turn. So when you were here, you are moving in a straight path. So your body is in a straight line motion. So your body is possessing an inertia which is tending to move in a straight line. Now when you are turning in right direction, your body is actually trying to move in tending to move in the forward direction, or continue or wanting to continue the straight line path. But when you are some external force is acting on you, your body, you feel that your body is being acted, a force is being acted on your body in the outward direction. So that's why you feel some force acting on you when you are making a turn, and that force we call it as centrifugal force. This is not a physical force, or it doesn't exist. It is just the reaction we feel when some inward force pulls ourselves. So in circular motion, only one real force exists, and what is that? That is the centripetal force. Okay, and the centrifugal force appears when we observe a motion from a rotating frame. Okay, so this is all about the centrifugal force. I hope that there is no confusion in between the centrifugal and centripetal force. It is just the effect you feel, and it is the real force which is acting on you to hold you in the circular path. So this is all about the circular motion and centripetal force and centrifugal force. So I hope you have understood it, and this is all. Uh, this is all that is present in the chapter, and from the upcoming videos we will start one new chapter. Thank you.